Welcome back. This is the lesson where you stop being a Fail2ban user and start being someone who can extend it. Lesson 07 handed you the regex toolkit. Now we put it to work by building a real filter for a service that doesn't ship one. An Nginx 401 brute force on Dotch API Josh login. By the end, you'll have a working Nginx 401.conf in filter.d, a jail wired up to it, and verified bans against your test log. And every step generalizes, so this same workflow applies to any service you need to defend. Before we touch any regex, lock this skeleton into memory. Every filter file you'll ever open has the same 3 sections. Includes is optional, usually just pulling in common.conf for date macros. Definition is required, and that's where 95% of your work lives. Failregex, ignoreregex, datepattern. Init is optional too, mostly for journaled hooks. For our Nginx 401 filter, we'll spend almost all our time in definition. The other 2 we'll barely touch. So where does that skeleton actually live? Fail2ban scans, etc., fail2ban filter.d, and the package already drops about 50 filters in there. SSHD, Apache Auth, Postfix SASL, the usual suspects. The trick I always use, don't write from a blank file. Copy the closest existing filter and edit. Here we're grabbing Nginx http auth.conf as our starting point and saving it as Nginx 401.conf. That's the artifact we'll shape across the rest of the lesson. And one rule, never edit the shipped files directly. Always use a unique name so package updates don't clobber your work. Now, before you touch that file, do not open a text editor yet. Step 1 is grep. Pull real attack lines out of the actual log and grab a few legitimate 401s too, because your regex has to match one and not the other. Step 2 is reading those lines like a diff. What changes line to line, what stays identical. The IP varies and becomes. The date and user agent vary, but we don't care, so they get plus and post, AP login 401. That's your constant. That's the attack signature you're anchoring on. Here's where it gets real. Attackers don't hit one endpoint. They probe variants. Same threat, different shapes. Login, v2 login, admin. So failregex isn't a single line. Stack multiple patterns, each on its own indented line, and any one of them matching counts as a hit. 3 rules to burn in. Indent every line after the first, include exactly once per regex, and stay lean. Every pattern costs CPU on every log line. Now flip the logic. Ignoreregex is your subtraction layer. It runs after failregex, and anything matching both gets thrown out before the counter ticks. You'll mostly leave it empty, but it earns its keep when a known good actor keeps tripping the pattern, an internal monitoring box, a pingdom synthetic check, that kind of thing. One word of caution, though. If you're filtering by IP, do it in jail. Local with ignore IP. Save ignoreregex for content patterns, user agents, query strings, things only the regex can see. Here's a trap that catches almost everyone the first time. Your failregex is perfect, but fail2ban regex still reports 0 matches, and buried in the output you spot date template hits, 0. That means fail2ban couldn't parse the timestamp, so it never even tested your pattern. The fix is datepattern, dropped right into the definition section written in stop-time codes. And remember, %% in the .conf file, %% on the command line. That one detail will save you 20 minutes of confusion. With the timestamp issue solved, your filter file is complete. Now you ship it. 3 moves. Confirm the .conf is sitting in filter.d, run fail2ban regex against a real log to prove it matches, then add a short jail block in jail.local where the filter name matches the file name without the extension. Reload, check the status, and you should see the jail report back as alive. Don't skip that verify step. A jail that silently failed to load is worse than no jail at all. But sometimes you ship it and nothing happens. So here are the 3 failures you'll actually hit, ranked by how often they bite. First, date template hits 0. Fail2ban can't parse your timestamp, so your regex never even runs. Fix it by adding a date pattern in the definition section. Second, failregex 0 total. The date parsed, but your pattern doesn't match. Rebuild it piece by piece, starting from just host. Third, matches but no bans. The pipeline works, you just haven't crossed max retry. Drop it to 1 temporarily to prove it, then tune back up. And here it is. Every step from this lesson collapsed into one file you can ship. Notice the skeleton holding it together. Includes pulls in common.conf, then definition carries all 4 failregex variants, the pingdom ignoreregex, and the date pattern for Nginx's bracketed timestamp. 4 endpoints covered: API login, API v2 login, admin, WP admin, monitoring traffic excluded, timestamps parsed. Run that fail2ban regex command at the bottom against your access log, and you've got a production filter. Step back and look at what you actually picked up. 6 skills. Recognize the skeleton, find real attack lines, generalize the variable parts, stack alternatives, subtract false positives, and pin down the date pattern when auto-detection gives up. That's the whole loop. Next time a service doesn't ship a filter, Caddy, Synapse, Plex, some internal admin API, you're not waiting on the community. You write it yourself. So Lesson 08 is in the bag. Filter anatomy, the 6-step workflow, multi-line plus ignoreregex, and Nginx 401.conf shipped to disk. But a filter that detects without an action is just expensive logging. Lesson 09 is where we wire it up. IP tables, multiport versus NF tables versus IPset, stacking ban with email and webhook in a single jail, and writing your own action.d files. See you there.